lecture, we learned how we can use interpolation using Newton method for doing our calculations. Remember that? Okay. So this lecture we want to talk about Lagrangian method. Any of you know about this method? Have you heard about Lagrangian method for interpolation? No? Nobody? So, just do you know about interpolation in general? So interpolation is an assumption. When you have several data points, you want to assign. It's a good idea. Did you tell it that? Yes. Yeah, it's a very good idea. There is no reason to. No, not like this. It's good morning. Good morning. So when you have several data points, you are able to use those data points for some assumptions. You want to conclude something from those data points. I'm talking to you. I am talking specifically to you because you wasn't in the class last lecture. You want to use the data points, and if you have data points, you cannot do anything with them because you cannot do derivation, integration, because they are numbers. You cannot do anything. You don't have access to the function. So with interpolation, you define different methods how you can assign different functions for your data points that you have. In last two lectures, we learned about doing that in exact way. We were defining how we are able to apply that to our system and define functions with our system. Last lecture, we were learning about Newton's method, and which is the approximate method that we can use for applying the functions to our data points. This lecture, we are learning about another method that I call it the Lagrangian method. This is a little different than what we were doing last time with Newton method, and it's very handy and interesting. This one is also, at the beginning, seems to be not simple, but it's gonna be very simple. So, as we were talking about, when we are dealing with different number of data points, we are talking about different order for our functions. If we have only access to 2 data points, with that I mean that if I have 2 points of my function, I don't have access to know exactly what is the shape of my function. I don't know what is the function f of x. But what I know is, I know what is this point, what is this point, which the first one is x0, f of x0. Second one is x1, f of x1. And if I have more data points, I can have different data points, different x's, different f of x's, and so on and so forth. The lowest order approximation was when I have access only to 2 points of my function, x1 and x0, and f of x1 and f of x0. That one was which I could apply a function, which was what? What was the function? It was a linear function, right? If you only have access to 2 points, you can only talk about linear function, because I know this point, and I can find what is this line from those 2 points, because that's all I know about my function that I have. And I cannot just predict anything with that. But as long as I know what is this line, like if I have x0, f of x0, and x1, f of x1, you can simply able to draw this line that consists of these 2 data points. Everybody agree? Do you agree? You can simply find the slope of the line, and you can have everything about this line. And if you have another point here, like x prime, you can predict what is f of x prime, because you know the function of the line, and then you put the value of x to be x prime, and you can find the value of that line for that x prime point. and so on and so forth. But that is the lowest approximation we can make. I haven't talked about any specific method yet. But I'm just reviewing this for you because you wasn't here the last few sessions. If one step further is if you have access to 3 points for your function. If you have access to 3 points of the function, you can assign a quadratic function, something with x squared plus ax squared plus bx plus c to your function, because you have access for 3 points, and based on those 3 points that you have, you define what is this quadratic function. If you have 4 points, you can assign a cubic function, ax3 2x plus d. That's your cubic function. And as the number of points is more and more, you can go to higher and higher order of function. But that is the subject of when we were using the direct calculation. We weren't using any specific approximate method for finding these functions that I'm talking about. Last week we were talking about approximate method, like we called it Newton interpolation. This is on lecture 11. You can go through it and have a look and see how it works. And today we are talking about another approximate method, and this is the Lagrangian method. This is the Lagrangian interpolation. So we are talking about linear Lagrangian interpolation, quadratic, cubic, so on and so forth. So again, the same subject. We have access to some points of our function, and we want to be able to find what is the function look like. So for Lagrangian interpolation, there is the main thing is a little different. I'm trying to see if I can find it. So I call the function that I have, because as you may remember, based on if you are talking about linear, quadratic, cubic, and so on and so forth, we call it fn of x. It depends. If it's linear, we call it f2 of x, f3 of x, f4 of x. It depends on how many data points we have. Okay, so I call my fn of x as a function p of x. It doesn't matter. The main thing is that I define that as a summation of the, I call my fn of x to be equal to, at the beginning it's not that handy, but then after 2-3 minutes you're gonna be able to find out what I mean. It's summation k equals to 0 to n l k of x f of xn. This is how I'm gonna define my function. But we have a problem. I don't know what is lk of x, and I have to figure it out. What do I mean by that? But what I mean, this fn of x is that function that you eventually get with respect to the order of your calculations. If it's linear, quadratic, cubic, it can be different fn of x's that you have. Is equal to summation from k equals to 0 to number of points that you have for your calculations times a multiplication of a constant that you call it lk of x, which I explained to you what is that, times f of xn. f of xn is the value that you have for a specific thing that you are doing the calculations. But for defining what is lk of x, you simply define it as summation. Summation is a product, that means multiplication of all x minus x I divided by xk minus xi. So what I mean, this is Lk of x, okay? It's some multiplication of all these terms when as you see in your denominator,